Hi, everybody. My name is Dominic Seyler. I'm from the University of Illinois at Urbana-Champaign. And today I'll be talking about towards dark jargon interpretation in underground forums. This is joint work with Wei Liu, Xiaofeng Wang, and Chengjiang Zhai. Many of you are probably familiar with jargon, which are special words or expressions that are used by a particular profession or group and are difficult for others to understand. In our work specifically, we are interested in dark jargon. So you're probably wondering, what is dark jargon? These are benign-looking words that have hidden and often sinister meanings. And they're also used by participants in underground forums in order to hide their illicit activities. So an example here would be the word rat, which is basically code word for Remote Access Trojan. So it's an acronym. Another example would be the word popcorn, which is often used in underground forums to refer to a type of marijuana. And ecstasy is a word that is often used to describe MDMA, which is a psychoactive drug. The motivation behind our work is that identifying the real meaning of these dark jargon words is essential for understanding the cybercrime that is facilitated through social media platforms. And existing work has already been successful at detection of dark jargon terms, but the interpretation of the meaning of the words is still an open issue. So to counteract this problem, we propose a general framework where we use words with no hidden meaning, which we call clean words, as a direct explanation of dark jargon words, which we call dark words. And we create a mapping function from a dark vocabulary or a vocabulary of dark terms to a vocabulary of clean terms. And this mapping can be probabilistic, where basically for each dark word, W sub D, we obtain a probability distribution over clean words, W sub C, in our clean vocabulary. A concrete instantiation of that general framework is that if you're given a dark corpus C dark and a clean corpus C sub clean, we build a joint vocabulary, which is just the most frequent words in the union of the two corpora. And then for each dark word in the dark corpus, we find a clean word that expresses the hidden meaning of that dark word. And we propose two methodologies to achieve this mapping, where the first method is a word distribution modeling and Kullback-Leibler divergence method. And the second method is something that has been introduced before, and it's called cross-context lectural analysis. And we will see that we slightly modify this approach to make it suitable for our setup. So starting with the word distribution modeling and KL divergence method, the intuition here is that a dark word like rat will appear in different contexts than the clean word rat would appear in. So its context would be more similar to the clean word malware as it would be to the clean word mouse. And we build a word distribution for each of the words in our vocabulary using a sliding window approach, where we basically look at a number of preceding words or words that are following a certain target word. And this is done separately for our dark corpus and our clean corpus. And this will result in two probability distributions, where given a dark corpus, we have the probability of a dark word, and given the clean corpus, we have a probability of a clean word. And to look at a specific example here, and to look into these probability distributions, we can see on the left-hand side, we have the word rat in our dark corpus, and the most likely words are, or very likely words are, computer and Windows. If you look at the word rat in our clean corpus, we get words like scared or running. And if you look into malware in our clean corpus, we see that words like antivirus and computer are more probable. So there is a higher overlap between the malware in the clean corpus and rat in our dark corpus. So once we have these probability distributions, we can get the dissimilarity of two words using KL divergence, where the dissimilarity is for a dark and a clean word. It's just computed as the KL divergence of their probability distributions. And then for each dark word, we basically define its hidden meaning as the minimum overall clean words of the similarity between a certain dark word and all the clean words in our clean vocabulary. The cross-context lexical analysis method analyzes the differences and similarities of words across different contexts. And here, contexts are defined over document collections. So this makes this method applicable to our problem setup. And here then we use word embeddings that are trained on separate corpora, one on a clean and one on a dark corpus in our setting. And we then compute the similarity of the top k closest methods of a word in a separate corpora according to our embedding vector space. And we then modify CCLA slightly so it can measure the similarity of a pair of words compared to the original version, which only was able to analyze similarities of a single word. And then similarly as before, for each dark word, we then maximize the similarity according to CCLA over each clean word in our clean vocabulary. Our experimental setup looks as follows. We have two data sets where we have a dark corpus of posts that are scraped from 4 major underground forums. We also have a clean corpus, which is basically Reddit threads from the most popular subreddits. And then we have two experimental environments where we have the simulated clean environment, where we split the clean corpus and replace random words, which are then our simulated dark terms with individual placeholders. And we then map the placeholders in the first split to the original word in our second split. And since this is a ranking problem, we then measure the mean reciprocal rank of the placeholder and its original word. In our second setup, which we call the real world environment, we use a dark corpus instead of that simulated clean corpus. And then similarly, we map each word in the dark corpus to a word in the clean corpus. And since there's no pre-annotated data available, we then perform a manual evaluation of the word meanings that we detect in our environment. So starting with the results for our simulated setup, we measure the mean reciprocal rank for all words in the corpus and our simulated dark terms. So on the left-hand side, we basically have all words in our vocabulary. On the right-hand side, we're looking specifically into our simulated dark terms. And we find that the KL method performs well and outperforming the CCLA method, specifically for dark words by a large margin. CCLA performs better on all words, but as we saw, it's much worse for the dark terms. And we therefore conclude that the KL method is preferable for detecting and also interpreting dark words. As I said earlier, we also performed a manual evaluation where we basically look at certain or many of our dark word and clean word mappings, and then using a regular web search where we make use of the dark word and the most likely clean words, we do try to find manually the meaning of these words. And we see that our method is able to identify many drug-related terms and also some terms related to malware. So summarizing, I can say dark jargon are benign-looking words that have hidden and often sinister meanings, and they're used by participants in underground forums to hide their activity. We propose a general framework where we use words with no hidden meaning, which we call clean words, as a direct explanation of dark jargon words, which we call dark words. We propose the word distribution modeling method, where the intuition is that the word meaning is dependent on the context it appears in. And we use the differences in the context distributions to find a mapping from a clean word to a dark word. Our results show that we get a high mean reciprocal rank on our simulated data, and our manual evaluation showed the efficacy of our method. Thank you so much for your attention. If you'd like to learn more about my research, please visit me at dominicseyler.com. I'm looking forward to see you at ECIR 2021.